All right, hi everyone. Thanks for joining us today. We'll be talking about Unity Mars. We're kind of excited to dig into this, and now that some of you have gotten a chance to try out the product, we'll be going in depth and teaching a little bit more about the product. Let's go ahead and get started. My name is Phil, and I'm the product lead of our expert tools team, and Mars is our flagship product, which launched almost a little over 2 weeks ago. And with me, I've got Andrew.
Hello, everyone. I'm the content lead for Mars, so a lot of like the example templates and simulation environments and demos and things like that you'll see is part of the great work of my team.
Today, the two of us are going to walk you through the basics of Unity Mars, how to get a project started, how Unity Mars works with other tools, and we'll end with directing you to other resources to learn more. We've got documentation resources so that you can get to advanced topics, and then we'll end with Q&A. We'll definitely make some time to answer some of the questions that you have. Unity Mars is an authoring environment. We've got specialized tools and workflow for creating intelligent AR experiences. So we want to make sure that you're able to develop the AR experiences that you really want, and you're not limited by just the simple tools that you've had so far. Unity Mars also comes with starter templates, which are pre-designed and customizable building blocks to help you get started, and they should help you learn, and will help you get ramped up and understanding of what Mars can provide. We'll touch on these in a little bit. So we made Unity Mars for folks who are creating a wide variety of AR applications. So whether you are working in an industrial environment and trying to create a training template, or you're trying to do digital twins type use cases on the factory floor where you're guiding workers through an experience, or you're looking for creating items for commerce applications at home, where end consumers can be previewing products in their own home and adapting them there, or telling stories, or working on games that appear in the home. And we also want to cover some IoT. We have a hope of covering IoT applications. So if you create an AR application that is a controller for a smart home or smart factory, that is another use case that we've created Unity Mars to cover each of these experiences. So why do we need Unity Mars? What problem are we trying to solve here? For augmented reality, you need to work with real world data to build your app. So as you know, that can be quite difficult. The real world introduces a lot of variables that you have to account for when you are developing your application. So what Unity Mars lets you do is use real world data in the editor. And we'll get into what that means. That starts with a simulation environment that will shave hours off of your iteration speed. So you won't have to build to device and be on site. And then we also provide a proxy authoring framework, which allows you to define your content responsively to how your device perceives the actual world. So we're drawing a lot of inspiration here. We call this fuzzy placement, and we're drawing a lot of inspiration from responsive design paradigms, where you define UI that responds to the size of a screen, a particular OS that somebody's on, or other types of accessibility features. So what does Unity Mars exactly do? So here, let's get into a little bit of the nitty gritty, and I'll transfer this over to Andrew.
Yeah, so Unity Mars, it's a specialized work environment inside the Unity editor. This includes tools and UIs that really give you the power to prototype, test, and deliver intelligent AR experiences, and to do so with a streamlined workflow. And we're going to go over the different panels right now. So we're going to start with first what you normally expect to see in Unity, which is the hierarchy and the scene view. And these are just sort of a logical view into your app, and then actually like a 3D view into it. And the one thing I would like to point out here is that this is an AR application, and you can see everything. Like, it's all there like you normally see in a regular Unity app. Next, you have the Mars panel, and this serves two purposes. At the top are shortcuts to create different sort of Mars objects that you might need. So at the very top are presets, and these are kind of like mini templates. They are commonly used things in Mars. Like, I want a horizontal plane, I want a vertical plane, an image marker, a face mask. Down below that is primitives, and these are more of like the base units of Mars. So all the presets are built from the primitives. And then we have visualizers, which just let you see the raw data. It's very good for just debugging or even letting users know what their app is doing. Then we have simulation controls, which control the simulation view. The simulation view includes all sorts of different environments that we built. You can supply your own. These can be like just pre-made scenes. They can be scans. They can be photogrammetry. They can be videos, recordings. It's whatever you need to simulate, we have it down here. Below that is the content hierarchy. And this is, so in our simulation view, we're running an instance of your scene. Even at a time, we're running it so that you can actually see how your AR app is adapting to the real world. So this includes all the things you'd expect to see in your hierarchy, except it also includes like match status. So you can see what parts of your experience are running, what parts aren't, where they actually are. Up at the top is the device view. So if you consider the simulation view to be sort of the scene view equivalent of your app running, then the device view is like the play mode equivalent. So you actually can run through with like a sort of like a average phone or HMD device, like plane finding and seeing everything be discovered in real time. This is really what reduces the iteration time to 0.
Yeah, and to add to that, so we've got the scene view here, and we're expressing that in simulation. So rather than having to build to your device and be on site, we've made simulation view pretty extensible and flexible. So knowing that we've got folks here who are interested in location-based experiences, outdoor and indoor, we have the ability to bring it. You can these are simply scene prefabs, so you can model your own environments. You can bring in other types of data, CAD data, model data, and you can also bring in photogrammetry scans. So if you have a specific scan environment in mind, simulation can be super useful, even if you have a very specific stadium or museum where you know your application is going to run.
So one of the big tricks with AR apps is that they're made to be used in real world conditions, but it's really hard, if not impossible, to actually define all the potential variables your user is going to encounter when using your app, like what objects are going to be in the environment, where are they going to be placed, how are they going to hold their phone, or like where is their head pointing, are they going to be sitting or standing? Even if you know like the exact physical layout, rooms can still be arranged. There's just so many human factors, like there's basically infinite number of human factors. So how do we handle that?
Yep, and we'll get into that and also in the documentation here. All right. Cool. So Unity Mars is unique as an AR authoring tool because it allows you to take in consideration of a wide variety of variables and providing you with a visual workflow that lets you move through the prototyping phase quickly and with relatively little coding, although it's powerful and of course extensible with scripting. So we've got here couple ideas for you to describe, and WYSIWYG and authoring in particular kind of describes your ability to drag and drop content directly into simulation and create a shortcut for intelligently having preset proxies configured for you to get you started and up and running very quickly.
Yeah, if you've built an AR app before, you know how difficult it is to test in all of these different areas. Even if you have an event space, you might not be able to always have access to it. Or if you're doing something outside, you can't really control for like crowds or weather. So it really is nice to have the simulation environment that can go and you can just jump into like even at like midnight if that's when you dev, like I know a lot of us do. It is so valuable to have the simulation environments.
Yeah, and what you're seeing here is we're driving around the scene and simulating something in between a generic HMD or mobile handset. And so you're getting we're in simulation, we have the synthetic stand-in for the real world, and we're performing raycast on the world, and we're implementing our own plane finding algorithm here inside the editor to give you a sense of how your application and content is actually going to perform in a real-world setting. Here we've got a gaming example using this mining robot and the collectibles here.
Yeah, and specifically about that data, like we don't make the plane finding look perfect on purpose because we really wanted to simulate a device you're using.
Yeah, so the planes on an actual mobile device, on an Android or an iOS device, aren't going to be perfect. These are not super high-powered devices with super expensive sensors, and so we're giving you these are design decisions to make sure that the simulation is somewhat reflective of how your application and content will appear on device. So Yeah, so hopefully what we showed here you so far shows you how drastically we can reduce the amount of time required to test your app. Since we're not able to bend the laws of time and space, we went for the next best thing, and we know all of you want a remote, and I'll just kind of like touch on that. That's definitely something that is still being worked on. So this is an independent effort that allows you to get started with AR development directly inside the editor. And hopefully solves for some of the similar problems that you have that you're trying to use a potential remoting application for.
Once you've built and tested your AR experience in Mars, you still want to test it on device and really wherever like a user interacts with it, and Mars enables that. So like what you've made and works in the simulator, you just deploy to a device and you can test it out, and it's going to be reading and reacting to data the same way.
Yeah, I want to really thank our partners at Sugar Creative in the UK, and they work with the Dr. Seuss Enterprises here and developed this amazing application on Mars. Andrew, do you mind like kind of touching on what features of Mars they use and how those are expressed in here and what we're seeing?
So yeah, right now, like what we're seeing is we're seeing the plane occlusion. So this can be done through visualization or proxies. So every plane is actually going and including digital content. And this is pretty much like a one-click feature. They're also doing floor finding. So not just finding floors, but finding or not just finding planes, but finding which ones are semantically important for actually placing the content in ways you'd expect. And then also just the general proxy workflow for knowing like the size of things so that the characters don't walk out of bounds.
Yeah. So here we're making it pretty simple to say, hey, grass should only appear on the floor. And we have, it's relatively straightforward in Mars to specify that, okay, I've got a floor and I'm gonna only attach my grass content there. So Mars ensures digital content reacts to the physical world in a believable way. And so this is important for training, for remote guidance. It's important for gaming. It's important for education. It's important for media. So you can use any type of real world data in your app. We have extensibility built into the backend here, and there's plenty of documentation to go figure out how to make that work. Today, right out of the box, we have plane finding, image markers, and face tracking have official support. And we're going to be adding plenty very soon. So we've got working on body tracking and object tracking, persistent anchors. We got a lot that we're excited to kind of coming down the pike. Excited to get that to you, that we're still working on. So by addressing the toughest challenges in each phase of AR app development, Unity Mars gives creators the ability to finally deliver AR experiences that live up to the end user's expectations. Digital content that seems to actually live in and react to the real world. And we give you the tools to do that in a way that doesn't break the bank. Now I'm going to pass it over to Andrew. And so we'll actually jump over to the editor, and we'll show you our basic robo demo, and he'll walk you through how to get started using Mars.
Thanks, Phil. I'm going to go and share my screen now. So what you see here is the Unity editor. It is a fresh project with Mars just installed. So this is what you would see after you've gone and signed up for Mars and gotten the installer package and imported it through the import package menu. So the first thing we're going to do is we're going to jump into Package Manager. And one thing I want to call out here is that we have extra sample templates. These are like the game and the training ones, the ones that seems like a lot of you are interested in. You just need to click this button to go and import the templates into the project. If you want your simulation view to look a little nicer, import post-processing. This will go and enable sort of like the occlusion and the really nice lighting in the simulation view. It works fine without it, but it's that extra step. The next thing is so in the little videos we've shown, there's all sorts of like raycasting and things like that. If you want to have that experience, you go to your project settings in Mars, and there's all sorts of data you can turn on. So like the raycast is the big thing to actually see when we're doing the plane finding, what actual rays are being cast out. So the first thing we're going to do is we're going to go and open a template. So in this case, we're going to go to you'll notice here in window, you have a new menu called Mars. and we'll go and do choose templates. We have a few options here. If you haven't installed the samples, you'll just see these 4. If you have, then you'll see 2 game templates and a factory training template. So I'm going to open up the simple game template. And if I look in my scene view, I have collision, a character, and collectible. And if I hit play, we'll jump into a simulation environment. And you'll see that we already have an AR app that we can run and test out. So I move around here a little bit. I'm going to get my character. Should start seeing objects here soon. Click my objects. So yeah, 1 click to have an AR experience that you could deploy the device and test out. So let's start bringing up that Mars view that we were showing off. So first we're going to do is we're going to go to Mars, and then we're going to go open our Mars panel. I'm going to dock it to the side here. Next, I'm going to go and open up our simulation view. One Unity workflow feature I'll call out really quick because you might need to switch between Mars and non-Mars views very quickly is the layouts. So if you go and click Save Layout, it'll save like your current open windows and everything like this. So I usually have like a Mars and a non-Mars setup so I can switch between them, or if I have like an animation workflow. It's just a power user tip. Like it makes workflow so much faster. Yeah, so I'm going to go and first off, like, yes, we have lots of different environments, and you can go through and test out your application running in all sorts of different scenarios. I'm going to stop in this bedroom here. And if we look in here, we're going to go and see that we have, make my camera settings the way I like. In here, we have a simulated bedroom. We see our app laid out. So I'm going to go and hide all these objects. So anything I change in here will actually change in our simulation view in real time. So I can go and turn off the visualizer, which will also turn off our occlusion. I can go and, yeah. So I'm going to go and show how the scene got laid out in the first place. So to interact with real world data in Mars, you make something called a proxy object. And there's a few ways to do this. You can click this button here. You can go to the right click menu. These are all the same shortcuts. And what this does is this makes a link to something that it's found in the real world. And right now there's no data, so it can't match. But the actual inspector is telling us, hey, like users generally want a plain size condition, although they can match any type of data like image markers or faces or whatever else you pipe in. So we're going to add the plain size condition. And if we look at our content hierarchy, now we see that we have a match. So next, what I'm going to do is I'm going to go and drag in a crystal. I'm going to go and drag this into my hierarchy. And now I'll see our crystal is showing up on a vertical surface. So if you look at our proxy is made up of something called conditions and actions. So my proxy needs to be more specific. It doesn't just care about plane size. It also cares about the alignment of the plane. So I've gone and added an alignment condition. It defaults to horizontal up. And now we're actually matching with a table that we like. The other important thing about conditions is it's not just about what data it's matching with. It's also about your visualization in the editor. So for example, if I edit this condition, because I'm specifying a plane size, I actually have something visual to author against. So like, I know if I put this crystal in any of these locations, it's probably still going to be on the surface. And then the next thing I want to show off is the optimization workflow. So maybe I don't want to match with this table. Maybe I want to match with something else. What I can do here is I can go and click Compare in Simulation View. And this is going to point out all of the data that I can match with, and it'll also point out data that I can't match with. So if I click on this wall, for example, it's going to tell me the plane size is off and the alignment is off. If I click on this bed, everything matches, but I really want it to fit to this surface. So I can hit this Optimize button, and this will alter the conditions so that it is the match. So I'm going to hit Optimize All. Now my crystal's on the bed. So that's sort of the long way to make an object, and the faster way to do that is we can just drag and drop immediately. Mars knows enough about your scene to actually go and tell you what conditions it thinks you want. You'll notice there's a condition here that's not checked, which is height above floor. It's deemed that it's not necessary. And this lets you make sure that you're not matching to the floor, you're matching to tables of a certain height. We're going to leave it off for now. And you see that it's embedded in the surface, but we can just move it up because it's Unity. And then the next thing we want to show off is we want to have more than one object here. So I'm actually going to go and make this surface be more forgiving. I like it being smaller and matching in more locations, but I want to have more objects. So what I'm going to do is I'm going to start making multiple crystals here. I can just drag them around. Notice like these things are not on a surface. So how do we make sure that we're only rendering that? And we can do something called an action. So conditions make sure we have certain data coming in from the real world. Actions do something with that data and translate it to something happening in Unity. So I can do something called show objects and bounds, and it's going to call out anything that isn't actually on the detected surface. So like that is building a proxy in a nutshell. And if we start re-enabling our objects, we'll go into the next aspect of this. So
yeah, I'll pause here and just kind of like take a step back and kind of think about, just kind of point out what we're doing here. So the word proxy, the reason we use that word is we're defining what to stand in. So in this case, we're saying, hey, every time I find a bed, I want to put these collectibles down or the mining robot down, or I'm looking for a nightstand or something like a nightstand or a countertop or something like that. And we're defining what that, we're adding constraints, we're adding conditions and actions that build off of that. So we're calling that a proxy. It's a proxy for a bed or a proxy for a nightstand. And that's a good way to kind of think about why it is we're making this infrastructure to set up your content.
Next question you might have is like, I have an AR object and it needs to move between multiple things in the real world. How do we handle that? Our game template includes this detacher script, and this will just pull it out of the hierarchy once it matches. You can see in our simulation view here, the character is no longer under the surface it's found. And this is just because it can move to multiple areas. The next thing is for the crystals. You can see that we're making them more than once, and that is because we put them in a replicator. Replicator is pretty simple. You can put your proxy or proxy group in here. Proxy group is just a collection of proxies that must match at once or have some sort of relation between them. And this will just continually duplicate this object. If I actually look in here, you'll see it just clones my original surface with crystals over and over until it can't find any more matches or until it hits some sort of limit that we've set up. It's a good way to actually just set up a rule for your scene. Last thing I want to point out is how we're actually generating collision for the world. So in this case, we have a proxy and we have a minimum plane size because we do want the character to fit on, we don't want him to go onto walls. We don't want him to go onto really, really tiny surfaces that couldn't hold him. So we have some conditions here. But instead of just positioning an object, we're doing this action called build surface. And what this will do is we'll actually go and take the meshing data and put it into our mesh colliders or renderers. So if I turn my visualizer back on, all these found planes, like they're getting used as mesh data for the collision for all these different surfaces. So I can go and make a purely visual experience with collision data and then actually have AR surface that same data as well. Then there's different levels of testing. I showed off play mode, which is just testing out everything at once. You can also go into device view. And device view lets you go, instead of seeing all of the data matching at once, you'll see data match slowly over time. So it's very similar to play mode, except that like the interaction's not happening. So you can go and actually change your conditions in real time. Be like, okay, I didn't expect that match to happen. Let me alter these things. And you don't have to go and reserialize it back out. You can just save because you're still in edit mode. Yeah, so that is the game template. And now we're going to go and jump into the training template for a view of a much different work case. Although what I found with the training template is that it is, all of the sort of pieces that we've made for the training template have been useful for every AR app that I've wanted to make. So once again, I'm going to go into choose template, and this time I'm going to choose factory training. The factory training template is meant to be used in our factory environments. You can adapt it to work elsewhere, but it's by default, we expect it to be in the factory. I'm going to set it to simulation controls. And really quick, I'm just going to run through and you'll see what you get when you're running the training template. So you're going to have this UI here. If you're running on a phone, you'll actually have a floating UI. Or sorry, if you're running on a...
Just for everyone, since we have so many folks who aren't coming from an industrial context, I'll explain kind of what the use case is here. So often in industrial AR use cases, we've got a worker. We're training a lot of workers on how to use machinery, how to work in a warehouse. And what we're doing is creating an AR application that can guide a worker and train them on how to use different pieces of equipment and where those pieces are on the factory floor. And so what we set up here is a canonical example that you can reference when you're trying to create that kind of application. Also very useful if you're trying to guide someone in a media and entertainment. If you're trying to tell a story, you'd be using similar interfaces. So you'll kind of see the similar tech being used, kind of depending on the different types of use cases that you have in mind.
Even in games, I found that like a user's like first-time experience running an application, having this sort of walkthrough is very useful. Even the pieces of like, hey, you need to look at this thing now. XR is notoriously hard to actually go and get people to pay attention where they need to. And this system really is about focusing users' attention. So pretty much if you're using AR, you'll probably want this or something like it.
Yeah. And since I do see a question here on kind of what kind of tracking is being provided in the example, we're making use of 3 pieces of tech with Mars here. We're using image markers, we're using plane finding, and we're using forces. So that gives you a starting point for developing a factory application. Of course, we would want to extend this further in the future with if you have persistent anchors or more specific scan data, we're using object targets and the like. But for now, we're kind of giving you a sort of an MVP on how you might build this type of application.
Yeah, and I'll show that in a second. The training template is really agnostic of the relocalization. It really just cares about a proxy, which surfaces any data from Mars. And what the template's done so far is it's made sure that we've gone close to our device, and now it wants to focus our attention on the screen, put some content, go and have some interaction to continue. Allowing us to go and look at the status of the device, and once we're there, we'll get some more instructions, and then we manually complete our experience. So it's a really small kernel of training, but it has all of the pieces you need to build out a very rich interaction. Now in the scene view, I'll go and show off just what is happening here behind the scenes. So the first thing we have is our menu, and this is sort of turn off gizmos here. This is the version that's floating in space. So this is the version you interact with like an HMD. Then we have all of the different sort of content that goes into our menus. And we have these separate here because sometimes we want to put it in the menu. And then like in this example, this step text, we're actually throwing into the real world. So you can actually see it in context. This can actually be conditional based on whether you're wearing a headset or viewing on a phone. Sometimes it makes more sense to have like the device that's based on form factor. It makes more sense to have the text or instructions in the context of the real world or just right in front of you. So we can adapt based on your device. So if we look at our walkthrough, this is sort of the guts of a training template, is made up of a series of steps. And all the steps we have here is first relocalize, go to the thing that we want to interact with, do an interaction, approach some piece on the machine, and then observe the results. And each of these steps is made up of a really simple script. It has objects that it can enable or disable during that step, extra actions, and these are just Unity events, so like any kind of script you want to call. And then these options to auto progress or block. And I'll give an example of this. So the first step is relocalizing, and this step has to block because until we know where we are in the space, we can't show any of our digital content. The next concept is autocomplete. So once a step is done, we don't need to have a user manually go forward. We can just move them on to the next thing. Last, we have what we call walkthrough triggers, and this one right here is proxy found. So what we're saying is we want to wait till a piece of Mars data is actually matching against the real world, and then the step can go on. a Mars proxy is what we use to relocalize. So in our case, we are looking for a image marker. Actually, this is really cool. So our image marker condition, you just select an image from any marker you've set up in your Mars session, which is right here. You can go and set up a marker library. You can add markers to your scene with this synthetic image marker button. So you can actually go and have your simulation scenes have image markers as you expect them to be set up in the real world. And then instead of looking for plane data, now you're looking for marker data. You'll still get like bounds and anything that's you'd expect to get with that, which is one of the really powerful features of our conditions and actions system. So once we've gone and found our proxy, it's going to be positioned. Actually, let me go and show here. So when I made this object, I added a reference model. So the proxy itself has the visualization for it is the image marker. And I've gone and positioned my reference model to be roughly where I'd expect it to be in our simulation environment. And now because I have a reference model of my device, I can place all the content relative to it. I know that wherever I place digital content relative to this image marker, it'll match up with my device in the real world. So I'm going, like, I can place like my arrows. I can place where I want users to approach to actually activate a step. Everything I need, this is just, once you've actually matched your proxy, now you're back in the familiar realm of digital authoring. Yeah, if I go to the next step, you can see it's another walkthrough step. Excuse me, this one, instead of waiting for a proxy to be found, it's looking for proximity. So it's making sure that two objects are close enough to each other, which is our user and our proximity target. So once the user is close enough to this object, the step can continue. The user is another Mars proxy. In this case, we're using a semantic tag. Mars supports semantic tagging of a very rich system. It's pretty much whatever your device can provide, or things that we can set specifically. So we are specifically exposing the user, tagged as user. We're doing this through something called synthetic data. And this just goes and takes Unity data and puts it back in the Mars database, which we'll go to, we'll go after this. So it looks the same as anything that your device has seen. It is all the same kind of Mars data. Yeah, so like the first step goes make sure that these two objects are close to each other. The next one is a custom interaction. And I'm gonna go and just try to show off this script real quick because it should be pretty simple. Yeah, I can even fit it in the inspector window here. It's really just a, you can write your own triggers here. It's designed to be really simple to script up so you can hook up to IoT systems. But it's really just filling in like a few-line function of, has some sort of event happened? If so, the step can continue on. So in this case, it's checking, has a UI button been pressed? After that is another approach target. And then next, the next thing that's important about this is that you can have multiple triggers. So in this case, we don't want to just be near an object. We want to be near and looking at it. So this is how we have the gaze trigger. And then in this case, sometimes we can detect when we move on. Sometimes we want users to just sort of use the honor system, like read some instructions. So in this case, we turn off auto progress, or sorry, turn off auto progress, and then they can just use the arrows to move on. And after that, then we just display that the training is complete. And then last but I'll show off is the menu. So the menu just gets filled in automatically from all of the data in the walkthrough. So it builds out all the entries you can skip to, gives you the navigation back and forth. The training actually works without the menu. So you can go and delete that object. You can make your own menu. This is just what provides that you have a starting point that lets you get running right away.
All right, so now we are going to talk a little bit more about how we handle different data sources, data coming from different sources in Mars. First, Andrew, do you mind touching on this one for a second?
Yeah, so I alluded to this previously. Mars goes and it sort of has a universal database of all of like the data coming into it, whether it's coming from like regardless of source, whether it's our simulation or whether it's hardware or cloud scans, anything. Everything that goes into Mars has a API conforms to, which gives the data a semantic tag, and it goes and makes sure that it's in like the same kind of coordinate space. And this, because we have this sort of universal definition of data, that's how we're able to make these conditions and actions that act very richly with the data and works between multiple sources. It also lets us have something called reasoning APIs. So when you author a scene in Mars, we know what data you need and in what context. Then we have reasoning APIs that can look at the data that is being provided to Mars and the data that's the user's asking for. And where there's gaps, we can run specialized scripts to fill in the blanks. So some devices will go and give you floor data, like an iOS device will actually give you like a floor plane. Other ones won't. So if we see that the user is requesting a floor plane, but their device isn't providing it, we can run a script that'll actually analyze all of the data in the scene, like all the different floors, and go and start adding semantic tags to them. So the device doesn't have, like the actual app that you've made doesn't have to handle this. It doesn't have to have any special branching logic. All of your apps stay very clean. These reasoning APIs just kind of fit in like Legos. Yeah, and this is sort of a little bit of a diagram of how everything fits together. So we have like hardware from cameras, like your phones. We have data from computer vision, like these are things that are running on your phone. Like I'm doing ML, and it's going and providing like, here is 2D bounding boxes of where objects are. And then you have like real-time data from your devices, like your phone planes and things like that. A reasoning API could go and say, like, if I have 2D object semantic tagging and I have planes, here's a script that'll go and figure out where the two actually line up in 3D space and start tagging my planes. That's an example of like a reasoning API you can write. And then all of that, all this data, regardless of where it comes from, is what is accessed through our conditions and queries. And then anything in our simulation view is also piped in through that same data interface. So it all looks the same to Mars.
Yep. So another, so something that we get a lot of questions about, what does Mars have to do with Air Foundation? How do they interact? And the truth is we work really nicely and really well with Air Foundation. So Air Foundation gives AR creators an ease of building on a framework purpose-built for AR. So you can define content against one API, and then we handle an abstraction that allows you to switch between different platforms seamlessly. So this gives you that extensibility of building once and deploying across ARKit, ARCore, Magic Leap, et cetera, et cetera. And so Mars very much builds on top of what Air Foundation already provides. So we depend really nicely on Air Foundation. So if World Understanding is coming through Air Foundation, through a really well supported hardware and software providers that integrate with Air Foundation, we have a really nice stable API that allows us to provide workflows and simulation and runtime functionality that sit on top of those APIs. With Mars, you also have the ability to extend that further. So if you have some of your own hardware that you're making, if you're at a hardware company, or if you got your own software provider algorithms that you want to run, you bring your own data in various senses, you're also able to do that as well. So you have some, so the backend and reasoning engine here is extensible, and the APIs are there for you to bring your own sorts of world understanding. We'll of course be adding different types of world understanding as that comes through Air Foundation, and then in certain cases we may consider kind of serving more niche needs depending on the use case that you have. But yeah, hopefully this should create some clarity. Air Foundation, Unity Mars works really nicely together, and we very much feed back and forth and provide nice reinforcement to the success that we're hoping to bring a fully featured AIR authoring solution to you all. So for further resources, so we're going to jump to Q&A in a second, but for further resources, please come talk to us at forum.unity.com. There's a Unity Mars forum. Our whole team is super active. We're engaging with folks there. So I'll respond to you, Andrew will respond to you. You can also reach us on Twitter, but that's not necessarily just for this type of thing. We've got documentation at docs.unity3d.com, and last but not least, you can sign up for Mars today, 45-day free trial. So you have a chance to get started, and you can, cancel that yourself. Cancel the auto renewal yourself, so you won't get charged if you don't want to. So please sign up at unity.com/Mars. Kick off that 45-day free trial, and you can dig into everything that we've laid out here, and then kind of take it further. So thank you. So now we'll tackle some Q&A. All right. So I've seen a bunch of stuff in the chat, in the Q&A. So this is really great. I'm gonna tackle some of this in just kind of top to bottom in the Q&A. First question we have from Shinobu Takahashi is, can we use Mars for HoloLens application development with MRTK? There are some answers there. The answer is yes. So MRTK works with Air Foundation. I will say that there is a caveat. We are constantly adding HoloLens support, but plane finding is handled a little bit differently on HoloLens 2. And so we're bringing some of that support online as we speak. But yes, we fully intend to be supporting HoloLens and other Air HMDs. James Can asks, I'd like to know how spatial anchors are supported with Mars. So spatial anchors are something that we have coming on the way. We do depend on external partners. So we've got of course, the Microsoft solution and the Google solution. We are dependent on third parties in this case to bring that functionality to you. But we are working on that, and we'll have more to you, hopefully at some point. But nothing to announce right now.
And it'll be a proxy, so it will look like every other kind of thing you make in Mars when it's online.
Yeah. At $50 a month, will there be more of a direct support offering? So John Collins asks, at $50 a month, will there be more of a direct support offering included rather than just forums? That's a great question. At this time, we're primarily in the forums. If you do want to prefer an offline talk to our sales team, we do provide support services and training services as well on top of that. But yeah, for $50 a month, it's a very good question. It is, we are kind of asking folks to pay here. So we are very active in that forum channel and very much want to make sure that everyone feels like they're getting really good value out of what we're providing. We're hoping to shave countless hours off your development process. So hopefully as you dig into Mars, you'll find that you're getting a lot of value.
Yeah, I want to really emphasize, like we're checking the forums all the time. Like I wake up in the morning and all the East Coast people have like already made a bunch of Slack threads like, hey, these are the feedback we're getting from users. These are the things that need addressing, and like we jump on it right away.
Yeah, and most of our team, all of our team is in North America. So me and Andrew on the West Coast, and we've got some folks on the East Coast. So yeah, if you're in Europe, for sure, there might be a little bit of a delay there, but we're trying to answer your questions pretty efficiently. Does Mars work with Vuforia? A good question. So that's a question from John Stillman. I'll kind of punt that over. I mean, that's, Unity is doing partnership deals all the time with different platform providers. Currently, the support for Unity as a whole is handled by Vuforia. So I would direct any questions back to them. John Collins asked, will Mars seamlessly support AirKit 3.5 and the new iPad LiDAR? I personally am very excited about the iPad LiDAR. I have one myself. In terms of adding support, nothing to immediately announce at this time. Of course, we eventually want to do that, but we're kind of managing, keep asking us, if we gauge that there's a lot of demand for that, we'll kind of shift that in terms of priority on our roadmap. But nothing specific to announce right now.
The LiDAR does improve the plane finding. So if you run it on an iPad, you are going to get really nice data. You're not going to get the full meshing just yet.
Thomas Klein asks, does it support model tracker? So we do want to support that at some point. Again, this is another one where we depend on external parties. So we do have, I believe, there are, I want to make sure I'm precise here. XR object tracking is either already supported or soon to be supported in XR SDK at the Air Foundation level. So if you did want to implement that yourself, we will have workflows kind of shortly on the way. But that's another category where we're dependent on third-party providers. I should make a note. That's actually a good note to make a plug for. We are constantly trying to talk to third-party providers to provide world understanding, and we do very much. We're very interested in providing improved workflows and improved discovery for developers through Mars. So if you have third-party providers that you'd like us to work more tightly with, introduce us, tell them to reach out to us. I'm very interested in adding that kind of support all the time. Sai Krishna Bodhu asks, can we import point cloud data and have my own environment for simulation? Andrew.
Absolutely. You can absolutely import your own environment. In fact, we designed Simulation View to make that easy. You can be as fast as you want with this. You can do like a fully enclosed mesh. We provide a special shader that will actually cut inside of the mesh. We call it our X-ray system. So yeah, like we pretty much support any kind of scan and simulation.
Yeah, so on that note, like that's scan data is very important for location-based experiences. So if you're outdoor, you have a specific space in mind, super important. We want to make that clear kind of going forward through our documentation, through our sample content. That is a first-class use case for using Mars. So if you have that kind of data, please bring it in, tell us, see what you think, tell us if you have issues, but we're seeing success from some of our alpha customers around having imported point cloud data. Thomas Klein asks, does it support face tracking and body tracking? So we do support face tracking. We have the support that has shipped is support that we support face recordings. So we have videos that you can use right out of the box. If you do want to access your webcam, we do depend on third parties for providing that type of world understanding. Currently, ULSI provides some of that world understanding. So if you have an ULSI license, you'll be able to use the desktop cam with Mars.
Of course, if you put it on like your ARKit or core device, you will get face tracking. There we support like head pose, eye direction, depending on if the provider offers it, and expressions, so like eyebrows up and down, mouth open, that sort of thing.
Yeah. Body tracking, also note on body tracking, that is implemented, I believe, at the Air Foundation level. So we are figuring out where to sequence that in a roadmap, but it is something we're thinking about and will happen at some point. Sai Kumar Malapalli asks, can we develop our own simulation environment by scanning the world around me on the fly and creating a mesh inside the Unity editor? And that dovetails nicely with a question right after that, which is from an anonymous attendee. When is the companion app going to be released? So we're actively working. So the next major product release from our team will be our mobile companion app. So that'll be out later this year. So in a couple months. And we'll have a kind of a closed beta sooner than that. So very interested in making sure that we provide that kind of functionality. We think it's super critical. We agree that providing that on-device world understanding, being able to actually capture, see how a device actually sees without having to guess. Right now you have to guess on the desktop editor. So we'll have that up very shortly, and stay tuned. Yes, this recording will be made public, I believe. Next question is, why isn't there a free version for everyone? Okay, cool. Yeah, I definitely want to tackle that question. So we, at Unity, our mission is the world is a better place with more creators in it. As we kind of evolve, we do take a long view on that. And so we want to make sure that we're providing a good value and we're able to invest further in these tools. So we want to, over the long run, make sure that we have a lot of good tools for you all. So as we kind of have rethought kind of how we were thinking about things, we do think that we're providing a lot of good value here. You do have free tools available to you through Air Foundation and what you can already do in Unity. We are taking that to the next level. So once you already kind of understand Unity, and then you kind of get into the problems of AR, we are providing advanced and specialized workflows that allow you to work even faster, work more efficiently, and iterate way faster for your AR projects. So we are adding a lot of value, and so we hope that you consider that when you're thinking about Mars. And of course, we'll listen to the community and see what we need to do going forward. But yeah, definitely hope that you find, try it out. You have 45 days to try it out free. Let us know what you think. Hopefully you find that there's a lot of value there that's worth paying for. Cool, related question. Yeah, so I think, so David Barros asked a similar question. Why does it cost money? Why are we charging extra on top of the Plus and Pro subscription? Similar answer there. I'm not going to kind of go further into that. We'll kind of just kind of talk about that. Unity is serving, and it's something that folks should be excited about. So if you're working on game development, we have more and more industries and customers that we're serving through our real-time 3D engine. And so we're serving different types of customers. We're still figuring out different models for serving different kinds of customers. And so you'll see different types of things that we'll try. So these are things that we're trying. We're making different decisions depending on which customer audience that we're serving. And so that'll be a case-by-case basis. But we're working on it, kind of bear with us as we figure it out. Amelia Borderline asks, sorry if I mangled that. Mars will work with GPS locations. We are very interested in that use case, and we're doing some active development. Don't have anything publicly to share right now, but we of course know that city scale AR is a very valuable use case for AR, and we want to enable those workflows. So more to come, nothing to announce today.
You can simulate it in Mars right now. You have the geofence condition and you have the data for it. So you can simulate it in the editor right now.
Yeah, but it doesn't work out of the box. I think you have to bring a lot of your own world understanding there. Multiplayer testing, cloud anchoring, multiplayer testing, thinking about it, nothing to announce yet. Let's move on to the next one. I think we covered the iPad question. Students, educators, we are working on that. So nothing to announce yet, but we definitely want to make sure that students and educators, super valuable. All of us started kind of at a very kind of student education level when we came into to the tools. So we want to make sure that that these tools are available to that audience as well. Nothing to announce yet, but know that we're working on it. WebXR, not at this time. Yeah, nothing to announce yet. That's sort of a more long-term project for Unity. Will you be supporting URP soon? Yes, we are adding, maybe I'll kick that one over to Andrew. He might have better data, yeah.
Yeah, so currently we have partial support for URP. You'll be able to convert most of the materials over except for certain simulation materials. You could just set those to your default shader and you won't get X-ray, but it'll unblock you for the most part. We have X-ray, we have versions of the shader for URP coming very soon, actively working on it.
Victor Kidziak asks, I would like to ask about UI. Can I have basic UI buttons over the Mars scene? Yeah, so I think that training template that we provided should show you how to do that. Andrew, I guess you have more perhaps?
The answer is yes.
Yep. Cool. All right, now we're getting deeper into the questions, so I'm just gonna be a little bit slower on taking a look at what we've got here. Image tracker, we covered that. All right, and then we've got, all right, okay. I think we are, thank you, Siobhan, for the comment on my hoodie. Sweet. Okay, cool. So I think we have covered, I think, most of the major questions here. So again, if you have further questions, direct them. You can go to the forums. You can find, definitely you can find myself on Twitter. You can feel free to DM me. My DMs are open. And yeah, hope you enjoy Mars. We're really excited for you all to try it out. It's been a long time in the works for us. Team's been working on it for 2.5 years. 45-day free trial. Sign up unity.com/Mars. Get started. Dig in there and let us know what you think. And with that, I guess I'll close it out. Thanks everyone for joining us. Excited that so many of you were able to attend. Bye.
Thanks, guys.